Okay, big picture, how do we handle a big problem like this where we're trying to figure out the stoichiometry of the reaction, figure out the concentration of all four ions, what's limiting and what's excess? I want to walk through a real quick conceptual big picture here. First thing we need to do is figure out what our products are, and we're going to get lead chloride, so the positive ions go with the negative ions. And with our solubility rules, we know that that's going to be a solid, and then we're going to get potassium nitrate. And we need two of those. Okay, so we have a balanced equation, and what we need to realize is this is good for stoichiometry if we just need to figure out how many grams we need. But again, the bigger question is, what is the concentration of all four ions? So we should have a molarity and a volume of those chemicals, which allows us to calculate the initial number of moles. Now this is the moles of the molecule, so PbNO3, 2, and KCl. Okay, this 2 has nothing to do with it yet because that's a balanced equation thing and that's not how much you have. So this should give me the moles of KCl and the moles of lead nitrate. What we are interested in is breaking these down into 4 different ions. So there's 1 potassium, 1 chlorine, so that's going to dissociate 1 to 1, 1 lead, but then however many moles of lead nitrate we have, this 2 here shows us we're going to have 2 moles of nitrate. So we need to double that. Then we need to classify everything. We know that our net ionic equation is going to be the lead ions and the chloride ions turning into lead chloride. So this is going to be our limiting reactant problem where we're trying to figure out how much of these are left over, which one's limiting and which one's excess, and how many grams of solid formed. The other 2 ions, the KNO3, are spectators. So in order to figure out the potassium molarity and the nitrate molarity, we need to know how many moles, these are the 2 big questions, how many moles do we have initially, and then how many moles do we have at the end? The spectators aren't changing. So we need the initial number of moles of the potassium, but then we just need a final volume. So we have to add these 2 volumes together. So volume 1 and volume 2, they're going to combine together to get a final volume. We just need to divide by that because this is being diluted. The nitrate's going to be the same thing. How many moles of nitrate do you have at the beginning divided by the final volume? And remember that initial nitrate is double the lead nitrate. So that one's tricky. The lead, how many moles do we have at the beginning of the lead and the chloride? And then they're going to change by their coefficients. And we have to say, how many moles do we have at the end? Moles final. And then this will be moles of the solid at the end. This one we're going to convert to grams because we want to know how many grams of solid. One of these is going to be 0. We don't know which one. But one will be limiting and one will be excess. The other one, so the limiting reactant is going to be 0 molarity. The excess reactant, whichever one is not 0, it's just how many moles do you have? What's the final volume? So the moles at the end, whichever one is not 0, divided by the final volume. So there's a big picture of what it looks like. How many moles of each chemical do you have? The spectators are being diluted into a new volume. The limiting and excess reactant are reacting. And we just need to kind of process the numbers and say, how many moles do we have at the beginning of all 4 of the ions? How many moles do we have at the end? And what does that tell us about our reaction? We also want to think about these numbers conceptually in terms of drawing pictures, what the images would look like. You would have the limiting reactant would be gone. But in the solution, you would still see the 2 spectators and the excess reactant still floating around. And we saw this in our precipitation lab and different lab calculations that can go with that too. So I hope that helped. That was just a quick big picture of solution stoichiometry for section 4.7.